Let's see this. The population of a town was 2400 3 years back. Now the population is 3600. What will be the population 3 years down the line if the rate of growth has been constant over the years and has been compounded annually? So the important word here is compounded annually is given, right? So what does it mean? You could solve this question also the same way we are solving the compound interest cases, and also in real world also this is true. The reason is, if you have a population of x and over 1 year, if this population x is actually growing at a rate of, let's say, r, and has produced new population, okay, now for the next year even this population will also grow as well as this population will also grow, isn't it? So assuming that these people are not going to pass away in the middle, right? So if you assume that no one is going to die, then it is going to be same as the compound interest, right? Okay, now it is given that the population of a town is 2400, of a town was 2400 3 years back. So if you assume that this is the present, okay, now 3 years back minus 3 years, they are saying that the population is 2400, okay, and now they are saying that as of now the population is 3600. Now they are asking after 3 years what happens, what is the population here. So in order to solve it, you can assume that this is the principal amount and it has grown to this amount in 3 years and the rate is constant, and now they are asking about what is the amount after 3 years from there. So if you take this one as the starting point, this one is going to be after 3 years, and this number they are asking is after 6 years. Got it? So let's try to observe this. Now assume that the amount is p into 1 plus r by 100 whole power t. Got it? Now you can assume that the rate is constant. Therefore, for the first 3 years, whatever is the rate, for the next 3 years also you can assume that the rate is same. So for this one rate is same and this one rate is same, right? So which means every year the rate is same. Okay, if you assume that the rate per year is r, let's say there are 3 years in this, okay, and then 3 years in this, therefore r and r, right? So from here to here there are 3 parts, each of rate r, and the number of parts is 3. That is why I can say that this 3600 is a result of compounding 2400 at a rate of r% per annum for 3 years. Got it? 3600 is the result of compounding 2400 at a rate of r% per annum for 3 years. I can write this. Got it? And now they are asking what would have happened if 2400 is compounded at the same rate r by 100, y rate is same, for 6 years. This is what is asked. Okay, now if you observe this, we could write it this way: 2400 into 1 plus r by 100 whole cube whole square. The reason I am writing it that way is because I can find out 1 plus r by 100 whole cube, right? What is it? 3600 by 24, isn't it? See, 1 plus r by 100 whole cube is equal to 3600 divided by 2400, right? Now it is going to be, so 3 by 2, 12 3s, 12 2s. Got it? Now we know this value, 1 plus r by 100 whole cube value. Now I can directly substitute over here. Then what do I get? 2400 into 3 by 2 whole power 2. Now what do I get? 1400 into 9 by 4, 600. So 5400 is the answer. Got it? So here it is going to be 5400. And also you can see that one more way of solving it is, if you see that the amount grows in GP, GP means geometric progression. Let us say the first term is A1, the second term is A2, the third term is A3. Right? Here you can assume that this is A1, this is A2, this is A3. Okay? Then you can write it as A1 by A2 or A2 by A1 is equal to A3 by A2. Why? In GP, if you take the successive terms, the ratio is nothing but the ratio of two successive terms is nothing but the common ratio R, isn't it? Therefore, A1 by A2 equal to this one. So A2 square, you can see that it is A1 into A3, and so A2. So we want A3, right? Therefore A3 equal to A2 square divided by A1, right? So if this is the first term, this is the second term, and this is the third term, you could find out the third term by writing A2 square by A1. So since we didn't discuss about the geometric series, and since we are very much comfortable with this formula, I would solve it this way. The other way of solving it is find out that these are in GP, and once you find it out, you can find out this A3 value as this one square, A2 square divided by A1. Even that way you will get the same answer. Okay.